Recording started. This is case study number 12, Who Has the Power? Resolution by Corey Harlow. So first I want to talk about what case study number 12 in AP Environmental Science is and what it's about. It's called Who Has the Power? It's all about the different forms of energy and how they pose a problem to our environment. It also talks about renewable versus non-renewable energy sources and many other things. Now we'll begin. We'll talk about energy first. Energy is the ability to do work. There are two main types of energy. There's kinetic energy, which is that energy in motion. And then there's potential energy, which is stored energy. We can describe these two by looking at the diagram to the right here. This ball right here in the claw is potential energy. It's storing energy. It's not in motion. It's not moving. Recording started. Sorry. And then over here, when the claw releases the ball, it goes into kinetic energy as the ball is in motion and the energy is in motion. So the next term we talk about is an energy sink. And this collects a significant quantity of energy that is either lost or not considered transferable. And then finally, we talk about the law of conservation of energy. And this just simply says that energy cannot be created or destroyed, but can instead only be transferred. So let's talk about the forms of energy. There's mechanical energy, and this is the form of energy that puts something in motion. And there's chemical energy, which is energy stored in the molecules in chemical compounds. There's electrical energy, which is unbalanced forces in protons and electrons and atoms create moving electrons called electric currents. There's radiant energy, which is carried by waves. There's heat or thermal energy, which is motion or vibration of molecules in a substance. Then there's nuclear energy, the bonding of protons and electrons that make up the nucleus of an atom. So to the left here, we have nuclear energy and mechanical energy, the person moving his or her body to lift the weight. We have heat energy, in which the stove is creating vibration or motion of molecules in order to heat the substance. We have the electrical energy, which is we have the unbalanced protons and electrons in the atoms creating the electrical currents. We have the chemical energy, which is just the stored energy in, it looks like the hamburgers, and we have the radiant energy, which is carried by the solar waves, and I believe that's it. The next thing we'll talk about is renewable energy sources, and this is just energy that comes from natural resources that can replenish themselves. So there's 6 main types of renewable energy sources. There's solar energy, which comes from the sun, biomass energy, which comes from our trash, wind energy, which comes from wind and windmills, ocean energy, which comes from tides, geothermal energy, which comes from heat inside the earth, and hydropower energy, which comes from the water and its movement. Then we talk about non-renewable energy sources, which is what we're most familiar with, the things we use most in our household. And this is energy that cannot replenish itself and is only found in a limited supply. And there's 4 main types of non-renewable energy sources. There's oil, coal, natural gas, and nuclear power. Nuclear power is not considered a fossil fuel, however oil, coal, and natural gas are. And once again, these are the most common energy sources used in our household. The next thing we talk about is measurement, and this is kind of a little confusing. In the International System of Units, the unit of work or energy, so the amount of energy or work being done is measured in joules. For every small amount of energy, the erg is sometimes used. And erg is 1/10 millionth of a joule. So 1 joule equals 10 million ergs. Power, on the other hand, is the rate at which energy is used. The unit of power measurement is watt, named after James Watt, who perfected the steam engine during the Industrial Revolution. 1 watt equals 1 joule per second. Power is sometimes measured in horsepower, as you probably heard in your car. 1 horsepower equals 746 watts. Electrical energy is usually expressed in kilowatt hours. 1 kilowatt hour equals 3,600,000 joules. Heat energy is often measured in calories. This is something I found very interesting. 1 calorie is defined as the heat required to raise the temperature of 1 gram of water from 14.5 to 15.5 degrees Celsius. 1 calorie equals 4.189 joules. Recording started. The next concept discussed in this particular chapter is nuclear fusion versus nuclear fission. Nuclear fission is the combining of 2 molecules together. Nuclear I'm sorry, that was nuclear fusion. Nuclear fission, on the other hand, is the breaking of a molecule to create energy. Nuclear fission is used in nuclear power plants. So when we talk about a nuclear power plant, we're talking about the breaking or the nuclear fission of uranium or plutonium. And finally, the resolution. There's only one real resolution to this particular case study, and this is to attempt to reduce the amount of non-renewable energy sources we use each and every day at home. And I hope you enjoyed.